And to fully understand the engineering behind this ERA aircraft, I'm pleased to welcome now Mattia Padullo, Chief Technology Officer of Ora Aero. Shall I say buongiorno, Mattia? Ah, very good. Mattia, it is your team that actually worked on that aircraft, ERA aircraft.
Yes, and I'd like to join Jeremy in thanking them all, and everybody in the company has been involved in this great project.
Good. Bravo to everyone. So it is a new milestone achieved. Now, before we go deep into the techno details, let's say, of this aircraft, can you tell us a little bit more where you're standing as of today?
Sure. What we have just achieved is what we call a configuration freeze milestone. And we are still a couple of years before the first flight, planned for 2026, and the entry into service for 2028.
Let me stop you here. What do you mean with configuration freeze? What is it?
Configuration freeze is a milestone in which you get convergence of three different elements. First of all is that you have the right customer requirements, and we've done that by working with our key airline partners. The second point is that you ensure that those are feasible technically. And the third one is that you lay foundations for the industrial viability of the project.
Okay, so what is your main objective?
The objective for which we are designing ERA is first and foremost energy efficiency. Energy efficiency is the number of passengers and the distance they can fly divided by the energy you need to make this. So, of course, the highest it is, the best. But you can see that when you compare ERA with a current 19-seater, it's not only better than the competition in a single point, but over a range of operational distances you need to fly. And that's what is make this aircraft usable for our customers. And you do this by working on three different axes. The first one is chasing aerodynamic waste. You want to reduce that. The second one is that you want to reduce the weight per pax, and that limits you to use the best technologies you need for the airframe, but also to limit the batteries you need to use in this kind of aircraft. And the third one is to improve propulsive efficiency.
So precisely, how do you get to that propulsive efficiency?
Well, that was done by using an unprecedented hybrid system that we developed by using a combination of propulsive and power networks. Propulsion is fully electric and is done with 8 electrical motors on the wings. And then power is provided by turbogenerators and batteries. And the decoupling of those ensures that you can use always the system at the best spot point, regardless of the customer mission. And there are as well other advantages of this kind of system. The first of those is the modularity. You can, for example, offer to your customers short ranges in full electric mode, but also higher ranges or higher productivity version with the same kind of aircraft. Another important point is the fact that the aircraft is evolutive. And evolutive means that as battery technology will improve, the performance of the aircraft will improve over time.
All right, and Ora Aero has chosen to partner with Safran to work on the propulsion system of ERA. So I'm very pleased to welcome now Monsieur Bruno Bélanger, General Manager and EVP of the Power Division at Safran Electrical Power. Hello and welcome. Thank you for being here. One simple question, Monsieur Bélanger. How do you get in position in the electric aviation sector today?
As you know, first of all, I would like to remind Safran's strategy. You must know that Safran's strategy is mainly based on decarbonization, and you have 3 pillars in order to meet this strategy. The first one is to develop ultra-efficient gas turbine. The second one is the use of sustainable aviation fuel. And the third one, as you rightly said, is the electric propulsion. Should it be hybrid or full electric? So my name is Bruno Bélanger indeed. I'm in charge of the power division within Safran Electrical and Power. And our mission is to propose electric solutions, traditional solutions, even if I don't like the word traditional, meaning the generation and the distribution of electric power within the aircraft. and new solutions regarding electric propulsions. And we are currently developing a wide range of products here in this slide. Electric motors, namely Engineus, offering very high density in terms of power. We have a wide range with 100 kilowatt engines that is on board the Integral E. But we are also developing wider engines, and the last one being the Engineus XL that will go from 500 kilowatt up to 1 megawatt. The second one is what we call Geneus Grid. This is the distribution of the electric power within the aircraft, from the sources to the motors, the electric motors. The third one is what we call Geneus. This is the generation of electric power. It can be used associated with a gas turbine to make a turbo generator, as you showed, for example, on the ERA project. And the last one is Geneus Pack. We have the ambition to propose certified batteries. We do have some skills in terms of certification, and this is one of our ambition. So if we look at the Engineus 100, I do remind that the Engineus 100 is on board the Integral E. On this one, we are not talking about R&T. We are simply talking about development, and we are at a very advanced stage in terms of development. If I come back on the product quite quickly, because I guess you know it, it's a very integrated electric motor, fully modular and scalable. It has a lot of merits in terms of integration. First one, it's a direct drive electric motors. The second one, it's an air-cooled motor, so you do not need to implement a complex oil-cooled system in the aircraft. And the third advantage is it embeds its own electric power. So it's a gain in terms of integration as well. Concerning the development, just to highlight the fact that we are now very advanced, we are in the process of certifying the engines. We have obtained the DOA. The DOA is a Design Organization Approval from the European agency. Just to make it clear, it's the foundation to get the type certificate tomorrow. And it makes Safran Electrical and Power the third engine maker within Safran after aircraft engines and helicopter engines. And last but not least, we have made the decision to launch the product lines. So there will be several product lines. Part of them will be in the UK, but two of them, very important, will be based in Niort, not far from here, directly inspired from the automotive world, because we do believe that we will have to produce high quantities with the highest standards in terms of quality and on-time deliveries.
Thank you very much. Mattia, in a word, can you tell us why it's so important for you guys to work with Safran today?
Well, it's the easiest answer is that we need to combine the strong technological background of Safran with our need to get to the market, as Jeremy mentioned, within the decade. So we have a complementarity with that respect.
All right. Monsieur Bélanger, one last word, maybe?
Maybe one last word is to talk about the distribution. We are talking a lot about the electric motors. The distribution is absolutely key. The distribution, the function is quite simple. It's to carry the electric power from the sources to the users, and in particular the electric motors. So it seems to be very simple. Then you have to do it with being light. You have to do it being very competitive. But on top of it, it needs to be very safe. And you know, Jeremy was mentioning the level of voltage we will carry on this aircraft. We are talking about 800 volt. When you use 800 volts in the sky, you have some kind of physical phenomenon. So you need very robust component in order to protect not only the electric systems, but also the aircraft. And this is clearly the purpose of the Geneus Grid here on this slide. And just as a conclusion, and coming back to your point, I think it's very interesting to see the association between big companies such as Thales and Safran and companies, startups just like Aura. I think it creates some kind of aerospace pioneer atmosphere, and we do appreciate much the relationship we have with Aura.
Well, thank you very much for coming here today. Thank you, Monsieur Bélanger.